What's up guys, my name is Benny and today I'm going to show you how to write a simple machine learning program. I'm going to include a link below showing the source code on GitHub. So now I'm going to start a recording of my screen. The first thing we need is a data set. A link to the data set will be in a yet to be link, but once I upload the video it will be listed below. The data set is of just a whole bunch of horses, medical information. I can show it to you right now. The file is called horse.csv, and here you can see that the file contains the age of the horse, its pulse, respiratory rate, packed cell volume, total protein, abdomen protein, and rectal temperature, which is our body temperature. And then I think there's about 60 or 70 records, which is actually way too little to create a decent machine learning algorithm, but we're going to just use this for an example's sake. Okay, and then in addition to this, I created what they call a test data set, which will be used to see how accurate our model is. I'm going to show this to you as well. I'm just calling it test-set.csv, and there's just three records of horses. Again, this is way too little, way too few records, but I'm just doing this for an example. And what we're going to do today is write a Python program using the tflearn library, which leverages which is based on Google's TensorFlow library, which is their artificial intelligence solution. Okay, so first of all, we're going to create a file. We're going to call it horse or body temp for body temperature. So body minus temp.py for Python, and then open it up in a text editor. I like to use something called Kate. Okay, now we're gonna first import a math library called NumPy. Then we're gonna import tflearn, which automatically in the background imports TensorFlow, which we don't need to import separately. Okay, the first step is to load our data set into our little program. This is done as follows. We're going to use one of tflearn's functions called load CSV for this. Okay, and we remembered that our data was called horse.csv. Now, because tflearn does not, when we try to work with when tflearn tries to handle the data, it's not able to read strings. So we need to convert our strings into integers. And to do this, we can just write a quick function. For example, to make my point a bit clearer, there's an age column in horses, and it indicates young and old, but we're just going to use 0 for young and 1 for the old. Okay, we're gonna call our function fixed data. And what we're going to do here is we are going to iterate through all the records in our data, and we're going to change, as I said, the young entries to 1s and the adult entries to 1. Sorry, the young entries to 0 and the adult entries to 1. Okay, now this function will return data. Okay, cool. Now what we did is we changed all strings in our data to floating point values. Next, we have to fix our labels. Yes, there is a fix that we have to do in labels. The way tflearn is set up is that it likes to have arrays of arrays. So we're just going to quickly do that as well. Okay, now we pre-processed all our data and labels. Again, data is the information that we, in a machine learning situation, already have, and the labels is the information that we're trying to figure out, which in our case is the horse's body temperature. Okay, now next we're going to actually use the tflearn data, tflearn library to create a network, a deep learning network. Okay, so we're going to create a variable called net, which will be our network essentially. And what you can use tflearn for is create multiple layers to increase the complexity and hopefully accuracy of our machine learning network. tflearn likes you to indicate the shape of your data. So in this case, we have to tell tflearn that we are using a data with six columns, and we do this by typing shape equals none, comma six columns. Okay, now we're going to add our first layer to the network, which is called fully connected. Okay, now we're going to add another fully connected layer, just to increase the complexity a little bit more. And finally, we're going to add regression layer to the network, and also this is where we include our operations, which you can read up more if like on the tflearn Wikipedia, or their homepage basically. We're going to use a SGD optimizer. And together with mean square loss. And for the learning rate, we will use 0.01. Okay, now the next step is to define our model, and we are going to use a deep neural net and to train our model, which is for which we use the fit function. We're going to use m for our model variable. One argument to the fit function is number of epochs, which basically determines how many times we train our model over the same data. We're going to do this 100 times. And we're going to use a batch size of 16. Okay, show metric. Okay, next we're going to for testing purposes, we're going to import our test data. And since we're going to use the load._csv function again, what it does, it returns a tuple of the data and labels that you want to use. So the first indicated variable will be then the test for the test data without the labels, and then for the second, we're not going to use this this variable, but let's just call it hope, because it's the temperatures that we hope to that our machine learning model will return to us. And if I remember correctly, we called our test set test minus set.csv. And again, we need to pre-process our data, so let's quickly do this. Test equals fix, what did we call it? Fix data. And test again. Okay, now finally we are going to print out the predicted body temperatures for our for the horses in our test in our testing records. So I'm just going to type print. So first I'm printing just the input that we're going to provide. Then I'm going to print out a header for our results. Predicted output. And then now finally I'm going to run tflearn predict function on our test data. Oops. Predict test. Alright, let's hope we don't make any mistakes in this program. You can see it's only 40 lines, so this library tflearn helps a lot with, I don't know, maybe not taking shortcuts is the right word, but saving time. Okay, so we're going back into our console, and let's make sure we saved everything. Okay. And now let's try to run it. So we do that by typing Python and the name of our program, which is called body minus temp.py. Okay. So before I run it, I just want to say that I set up tflearn to run on the graphics card of my computer, which I would also advise you to do, because it makes the learning process much faster. As far as I know, you do need an NVIDIA card, but once you have one that's on Linux, it's actually not too hard to get it running. All you have to do is install what they call the CUDA toolkit, and I think cuDNN, I think it's some extension for CUDA, but it's all documented. If you go onto tflearn's website, they'll tell you exactly how to do it. Yeah. Okay, so now let's run the program, see if there's any mistakes. Yes, there is. Okay, in line 27, there is an invalid. Okay, this says the optimizer is invalid, so let's go ahead and look at it. Okay, I'm gonna start I'm just gonna start Kate from another window. Okay, the error was in 27. Okay, I believe the problem is that the optimizer is not called SGF, but it's called SGD. Let's try and run it again. Okay, there's an issue in line 31. That says tflearn is not defined. I think the problem is that we have to type tflearn. Okay, let's try it again. Okay, one more error in line 32. We have labels is not defined. 32. Oh, I mistyped labels. Okay. Running it again. Okay, here you can see that these training steps, these are all basically different epochs. So it means when we see these green values, that means it's training. At the end of our program, if you remember, we are printed out the data we used for testing, which is basically this array, and then our predicted body temperatures here. And now let's compare the predicted body temperatures to the real the temperatures we would we actually have for the test data. To do this, I'm going to just open up the testing file. So the first record should have a temperature of 38 degrees, and our predicted value is 34.67 degrees, so that's off by about 3.3 degrees, which is pretty bad. Our second prediction of 25 degrees, where we should actually be getting 36.5 degrees, is just terribly off, very inaccurate. We're more than 10 degrees off. And our final prediction for the third record is 32 degrees, and we will be expecting 37.2 degrees. So we can see that this model is terribly inaccurate, and the reason being, in my opinion, would be the fact that we only trained the model on 70 records, which is just much too little. Ideally, one should be training it on 100,000 or 1 million records to get a decent neural network. Let's just, out of interest sake, run it one more time. Again, all these, every time you see this record where it says training step 395, training step 400, training step 405, these are all, this is basically the training process, and this program were to run for a much longer period of time if the data was, the data set was larger. Again, our predicted output is, you can just see at one glance it's far off the actual body temperatures. And but what is showing us that the neural network is working is that we don't get the same predicted output, it's different, which is, I don't want to get into too much detail, but which is indicative of the fact that this is a more organic kind of type of program. Yeah. So thanks guys for watching. Feel free to comment below. And I'll see you in my next video.